All right, let's recap order of operations real quick. Again, we call this PEMDAS. The first thing we do in order of operations is parentheses or any other grouping symbol. So for example, square brackets or a fraction bar could also group just as easily as parentheses do. Then we do exponents, multiply and or divide left to right, and add and subtract left to right. So let's try an example with a fraction bar, because sometimes those throw some people off. So in this example, we're going to evaluate. Remember that word evaluate just means plug in. So we're evaluating 2x minus 4y plus 1 divided by 2x minus y for x equals 2 and y equals 1. So where there's an x, we're going to plug in a 2, and where there's a y, both places we're going to plug in a 1. So let's see what that looks like. The top of the fraction will be 2 times 2, and I use parentheses to plug in, minus 4 times 1 plus 1. And then the bottom of the fraction is 2 times 2 minus 1. This fraction bar is really a grouping symbol. So if you want, you can even put parentheses around the top and bottom. If that helps you. For a lot of people that doesn't really help. We just need to think of it as the top and the bottom are two separate pieces. So let's simplify what's in the top first. There are no exponents, but I do see multiplication. 2 times 2 is 4, and 4 times 1 is 4. Same with the bottom. There's a multiplication. 2 times 2 is 4. And then the addition and subtraction we're going to do in the next step. 4 plus 4 and minus 4 cancel. So we just get 1 in the top of the fraction. 4 minus 1 is 3 in the bottom. And then that's our answer, 1/3. There's no reason to think that fractions aren't numbers. They are. They're great numbers. There's no reason to put it in a calculator. And actually in chapter 1, we are not supposed to be using a calculator. So on your homework, they're going to expect fractions as answers, not a decimal that came from a calculator. So 1/3 is our answer, and that is the value of the expression when x equals 2 and y equals 1. But the idea of an algebraic expression is that x and y could be any value, and that this would take on a lot of different answers, depending on what x and y are. So those are expressions. An equation in math is when we take an expression and set it equal to another expression. What makes it an equation is the equal sign. So let's see what this definition says. An equation is a statement that two algebraic expressions are equal. In other words, an equation is a mathematical sentence that contains the equal symbol. The symbol is in between two numeric or algebraic expressions. Equations that contain variables are open sentences, meaning that they could be true or false. So equations can be true or false. An expression is just an expression. So we're not saying that this expression is true or this expression is false. It's just equal to 1/3 sometimes, and if there were other values of the variable, it'd be equal to something else. But when we start setting an expression equal to something, then sometimes for certain values of y, this equation will be true, and for other values of y, it might be false. And so that's what really makes it different, and we're going to do different things once we start setting things equal. So here's example, 18y plus 2 equals 106. So for some values of y, that's true. So for some values of y, that's false. Solving the equation means finding the value of the variable that makes it true. That's what when we say we're solving an equation, that's what we're doing. So a lot of times students will use like solving when they really mean plugging in, and we're going to try to avoid that. For us, evaluate or simplify means plug in, or but when we say solve, that's not the same thing. For solve, we're trying to find a value of the variable that makes an equation true. All right, so let's try an example. So we have some steps here, if that helps you have them like laid out. We're going to substitute a number for every occurrence of the variable. And then if what we end up with is true, then the number is a solution. And if we end up with a statement that's false, then the number is not a solution. So let's try it. Determine whether the numbers 3 and 4 are each a solution of the equation. So sometimes one piece of confusion is that there's really two different things going on. They want us to do two different problems, one for x equals 3 and one for x equals 4. So they're phrasing it in a way where they're talking about both in one, but we can only let the variable equal one number at a time. And then here's our equation. Notice because it's an equation, there's an equal sign. And we're going to plug in different values for x. So the first one, when we plug in x equals 3, it's 8 times 3 plus 2. And I want to know, does that equal 26? Yes or no? 8 times 3 is 24. 24 plus 2 does equal 26. So this is true. So x equals 3 is a solution. Let's try that for 4. X equals 4. Where there's an x, I'm going to put 4. I want to know, does that equal 26? 8 times 4 is 32. 32 plus 2 does not equal 26. This is false. So x equals 4 is not a solution. And that's all we mean when a problem says determine whether there's a solution. At this point, we are not expected to know how to solve for x. I know some of us have taken algebra before. So if you know how to subtract 2 and divide by 8, great. We're certainly going to get to that. But right now when it says determine whether the numbers are solutions, it really just means plug in for the variable and decide whether it's true or false.